these accelerators, I mean, they're serious pieces of machinery. The one that's being built in Switzerland right now, the Hadron Collider, is costing $300 billion. It took 5 countries to flip the bill for that one. And now we're looking for the X bosons and mini white hole black holes. And I'm like, well, at that point, you're dividing the vacuum. And basically, what I'm saying here is that instead of looking, and I'm not the first one that have said that, famous physicist Jeff Chu said it in the 70s, maybe instead of looking for a fundamental particle, we should start looking for a fundamental principle of division. And that's what I came to, is that instead of looking for a fundamental particle, we should start looking for a fundamental pattern of creation. Because if we understand the pattern, then it doesn't matter at which resolution we are observing the identity. We understand the principle behind the identity. Now we have the key to creation. And that would change a lot of things of the way we do physics and the way we think of the universe and how it creates and how it subdivides. I was really excited about this. I started to really study physics. I started to look everywhere to find how things work and where standard physics was at the time. Where did we go and where did we go wrong and what needed to be changed to make it do that, to make it look that way so that we could find that fundamental structure of creation. I was determined that I was going to find this in my lifetime. It was a big mission, you know. And so I went at it. And I started to study a lot. And now we're going to jump forward to me in Georgia Tech. I'm at Georgia Tech, Department of Physics, with the director there and other physicists, and this is an impromptu private meeting discussion with those guys. And basically my sponsors at the time brought me there to measure up with the biggest and most respected physicists, some of the biggest and most respected physicists in theoretical physics. And, you know, I'm there and they have equations everywhere, and we're talking about things, and it's a very small meeting, you know, but there's a few students, and there's a bunch of physicists there, and there's me. And the only thing I got with me is this book. It's called Gravitation. It's like the Bible of relativistic physics. And it's called Gravitation because when you pick it up, you know, you can really tell gravity is acting upon things. And I was, you know, going through the equations with them, and I'm talking about all this, and I'm really, you know, going through it with them, and I can see that there's a certain amount of irritation, and there's a certain amount of impatience with me because I'm asking very simple, fundamental questions. And everybody there is doing very advanced, you know, string theory physics and all this. And, you know, I'm always going back to like some fundamental things. And they're like, my God, what is this guy doing here kind of deal? And, you know, and so at one point, I pulled out my book, Gravitation, and I said, okay, after all these equations, which is a few thousand equations, on the metrical structure of space and then applied to the universal size and so on. The model of our universe at this point, and correct me if I'm wrong, is that the universe is expanding like a balloon. And I opened the book on page 219 and I pulled it out and I said, here's the picture of what we believe the universe is doing right now. It's expanding like a balloon, and the balloon has little pennies glued to it, and the pennies represents galaxies. That's the standard model. And the galaxies are moving away from each other as the balloon expands. And everybody's like, yes, Nassim. Where are you going with this kind of deal? Like, if you don't know this, go back and study, come back in a few years. And at one point, well, I'm saying, well, okay, I understand this principle. However, I have a question. Out of all these equations everywhere, what I want to know is where is the equation that represents who's this guy? And the whole room became really silent. And I could see that in the look of the students and the other physicists that there was a look of despair and stress because sweat was a little bit beading. And I could tell that they got worried because they thought, oh my God, this guy, he might just start talking about God. And we're at Georgia Tech in the physics department. We can't do that. and I reassured them very quickly. I started to draw, and I said, well, let's draw the rest of the guy. And what I'm trying to point out here is that in order for the balloon to expand, then the lungs of the person that's blowing into it have to contract. For every action, there's an equal and opposite reaction. Okay? One of the first laws of physics. So if our universe is expanding, then there must be something contracting, there must be some compression happening in order to get expansion. There must be a feedback between the expansion and the contraction. And that was my first clue to the relationship between the gravitational field and the electromagnetic radiation. And as well, it applied to my experience in life. Because really this is all based on my experience in life. When I was 11, I started meditating. My family came in contact with a young master of meditation that was 14 years old, and I was 11. And he taught me how to meditate. And when I meditated, it felt like I was turning my senses inwards and going towards the center of my existence. I was going towards the middle of my being. And I came, out of that, I found a logic in which there was an internal universe and an external universe. There was something going in and something going out, and the two generated boundaries. And that boundary is what we experience as reality. The thing is that in our society, the tendency is to spend a lot of time analyzing what's out and very little time analyzing what's in. Not only in our, social morphs, but as well in our physics and the way we do things. We explode things. That's how we build technology. Our concept of advanced technology is to put a bunch of fuel in a cylinder, put a bunch of people on volunteers on top, and light the bottom and see if they survive the experience, It's all based on expansion, on explosion, on radiation. Very little is based on contraction, on going towards the center, on implosion. And to me, there had to be a direct relationship. So I was really pointing that out.